Hello and welcome back to our channel. Today we'll be working on question 3 from the 2021 STEP paper 2. This is possibly one of the easiest STEP questions I've ever seen, so if you come across a STEP question that's easy as this, please do it. It's worth 20 marks anyway. Let's get started. Question 3. In this question, x, y and z are real numbers. Let the floor of x denote the largest integer that satisfies floor of x less than or equal to x, and let the fractional part of x denote the fractional part of x, so that x is equivalent to floor of x plus the fractional part of x, and 0 is less than or equal to the fractional part of x, which is less than 1. For example, if x equals 4.2, then the floor of x is 4, and the fractional part is 0.2. If x is negative 4.2, then the floor of x is negative 5 and the floor of x is 0.8. Part 1. Solve the simultaneous equations below. Part 2. Given that x, y and z satisfy the simultaneous equations 1, 2 and 3, show that the fractional part of y plus the floor of z is 3.2 and solve the equations. Part 3. Solve the simultaneous equations alpha, beta and gamma. Pause the video to have a think, and once you're ready, restart to see if you're right. Let's get started. From the definitions above, which I've relisted here, we have the floor of x is equal to 4, and the fractional part of y is equal to 0.9. This is because the floor of x must be an integer, which leaves 0.9 as the fractional part. We also have the floor of y is negative 2, and the fractional part of x is 0.6. Adding these numbers together, we therefore have x is equal to 4.6 and y is equal to negative 1.1. It's important to be able to do this part very quickly because this sets us up for the next part, part 2. So let's move on to part 2. If we take equation 1 away from the sum of equations 2 and 3, we have 2 of the fractional part of y plus 2 of floor z equals 6.4. We therefore have the fractional part of y plus the fractional part of z is 3.2, as required. Similarly, we have the floor of x plus the fractional part of z equals 1.8, and also that the fractional part of x plus the floor of y is equal to 2.1. Then, solving these equations as above, we have x equals 1.1, y equals 2.2, and z equals 3.8. And that's our answer. Now, let's move on to part 3. Using a similar method to part 2, we can gain that 2 of the fractional part of y plus the floor of z is 3.2. And similarly, we can gain that the floor of x plus the fractional part of z is 1.8, and also that the fractional part of x plus 2 of the floor of y is 2.1. Here, we have two choices for the fractional part of y, because the fractional part of y could be 0.1 or 0.6. In the first case, using the methods used in part 1, we can solve for x equals 1.1, y equals 1.1, and z equals 3.8. In the second case, we can use the same methods to solve for x equals 1.1, y equals 1.6, and z equals 2.8, and that's our answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.